dear students, in the previous class I have discussed about project scheduling. In that I have discussed about project crashing. Today another important topic, inventory models. So, in this lecture I am going to explain how to use Excel for making inventory decisions. So, the agenda for this lecture is to show how quantitative models can assist in making how much to order and when to order inventory decisions. Because in inventory management, these important questions, how much order, that is called Q, and the timing when it should be ordered, these questions we are going to answer. So, in this lecture the assumption is deterministic inventory models. What is the meaning of deterministic inventory models? We assume that the rate of demand for the item is constant or nearly constant and it will not change. Okay. So, that is the meaning of deterministic inventory models. The demand is known to us. The reference for this lecture is from this book Anderson et al. First, what is inventory? So, inventory refers to idle goods or materials held by an organization for use sometime in future. It is nothing but stocks. So, items carried in inventory includes raw materials, also a type of inventory, purchased parts inventory, components, sub assemblies, work in process, finished goods and the supplies which you have received from our suppliers. These are the example of inventory. Two primary reasons organizations stock inventory. Why inventory is required? The first reason is to take advantage of economies of scale that exist due to the fixed cost of ordering items. What is the meaning of this economies of scale? When you buy at larger quantities, okay, the cost of ordering will be less. That is the meaning of economies of scale. Second one, to buffer against uncertainty in customer demand or disruption in supply. Whenever there is uncertainty in the demand or disruptions, it is better to hold some inventory so that there will not be any stockouts. What is the importance of this inventory? Even though inventory serves an important and essential role, the expense associated with financing and maintaining inventory is a substantial part of the cost of doing business. So, when you say business, indirectly it is nothing but inventory management. Some professor used to say what we call it a supply chain management is nothing but it is integrated inventory management. Because in inventory management, what is happening, the supply and demand is matched with the help of this inventory. In large organizations, the cost associated with inventory can run into the millions of dollars. So, if you are able to reduce the inventory cost, if you are able to having right inventory policy, that will save lot of our money. So, managers must answer two important questions while designing the inventory policy. One is how much should be ordered when the inventory is replenished. So, that is the Q, generally the notation we are using is how much has to be ordered. Another one is when it should be the inventory be replenished, when we have to order, how much and when. So, these questions has to be answered. In this lecture we are going to answer that. The economic order quantity model is applicable when the demand for an item shows a constant or nearly constant rate and when the entire quantity ordered arrive in inventory at one point in time. For example, look at this figure here. When it was 0, I am ordering 1200 units. You see that the demand, when the demand is constant, the slope is right, the slope is constant. And another point is when I replenish here, right, immediately I will get another 1200 units. Okay. These the 1200 units I will get at a time. It is not that I will get initially 1000 then 200. So, these are the assumptions. We will study in detail about the assumptions in coming lectures. The constant demand rate assumption means that the same number of unit is taken from inventory each period of time, such as say 5 units every day. For a week, if there are 5 days, there will be 25 units. 100 units every 4-week period, because 4 into 25 100. So, the demand rate is fixed. Now, I am going to explain the concept of this all inventory management principles with the help of an example. What is this example? To illustrate this EOQ model, let us consider the situation faced by a cold drink company. The cold drink inventory, which constitutes about 40% of the company's total inventory, averages approximately 50,000 cases. With an average cost per case of approximately $8, the company estimates the value of its cold drink inventory to be $400,000, because 50,000 multiplied by 8. So, the inventory cost is 400,000. The warehouse managers decided to conduct a detailed study of the inventory cost associated with the company. The company is thinking about how can we reduce the inventory cost. So, the purpose of this study is to establish how much to order and when to order decision that will result in the lowest possible total inventory cost. That is what the company is planning. As the first step in the study, the warehouse manager obtained the following demand data for the past 10 weeks. So, he knows the demand from the customers for the 10 weeks. For example, week 1 2000 units, week 2 2025, like this. For example, 10th week it is 2000. So, the total demand is 20,000. So, 20,000 upon 10, so the average demand is 2000. Every week the average demand is 2000. Strictly speaking, these weekly demand figures do not show constant demand rate. You see that sometime it is not a straight line, sometime 2000, sometime 2025, sometime below 2000, sometime even see this even 1900 the lowest value, highest value is 2050. However, given the relatively low variability exhibited by the weekly demand, inventory planning with a constant demand rate of 2000 cases per week appears acceptable. So, we are going to do this analysis assuming that the average demand is 2000 cases per week. In practice, you will find that the actual inventory situation seldom, if ever, satisfies this assumption of model exactly. Many times the demand will not be constant, but we are assuming it is constant demand. In any applications, the manager must determine whether the model assumptions are close enough to reality for the model to be useful. So, in this situation, the problem which we are discussing, demand varies from low of 1900 cases to the high one is 2100, not 2050, there is a 2100 cases. So, the variability is not that much. So, the assumption of the constant demand of 2000 cases per week appears to be reasonably approximation, reasonably correct, even though there is a slight variation. So, now we have to do some compromise between ordering cost and holding cost. I did not explain so far what is this ordering cost and holding cost. I will explain in detail. So, the how much to order decision involves selecting a order quantity that draws the compromise between keeping small inventories and ordering frequently. So, what will happen when you keep a very small inventory? When you order, obviously you have to order frequently. What will happen here? The ordering cost will increase. Okay. So, you see that the total demand is, for example, say 20,000. Okay. So, what we can order? We can order maybe 100. Okay. So, when you order 100, so what you have to do? You have to order 200 times. Okay. So, what will happen? Every time the ordering cost will increase. On the contrary, if you keep large inventories and order infrequently, there will be more ordering cost. So, the first alternative can result in undesirably high ordering cost, which one? When we keep a small inventory, while the second alternative can result in undesirably high inventory holding cost. So, now we need to have the compromise between ordering cost and holding cost. That is what we are going to do now. So, to find an optimal compromise between these conflicting alternatives, what are the conflicting alternatives? High ordering cost and high holding cost. Let us consider a mathematical model that shows the total cost as the sum of the holding cost and ordering cost. Total cost is total inventory cost. First, we will explain what is this holding cost. The holding cost are the cost associated with maintaining or carrying a given level of inventory. These costs depend on the size of the inventory. When the size of inventory is more, the holding cost will be more. The first holding cost to consider is the cost of financing, the inventory investment, that is the interest rate. So, when a firm borrows money, it incurs an interest charge. So, that is your one example of holding cost. If the firm uses its own money and it experiences an opportunity cost associated with not being able to use the money for other investments because your money is blocked. In either case, the interest cost exists for the capital tied up in inventory. The cost of capital is usually expressed as a percentage of the amount invested. So, for this company, it estimates the cost of capital at an annual rate is 18%. Apart from this cost of capital, a number of other holding costs such as insurance, taxes, breakage, pilferage and warehouse overhead also depends on the value of your inventory. So, the company estimates these other costs other than the interest cost at an annual rate of approximately 7% of the value of its inventory. So, the total holding cost for the company's inventory is 18% for interest, 7% for other expenses. So, the 25% of its value of the inventory. So, we know that the cost of one case of the cold drink is say $8 with the annual holding cost rate of 25%, the cost of holding one case of cold drink in inventory for 1 year. So, 0.25 multiplied by $8 is a $2. So, the cost of holding an 1 unit for 1 year is $2. So, how we got this one? Cost of holding equal to I multiplied by C. I is your percentage. It may be interest rate or other, for example, here the cost of insurance, taxes, breakage. So, these has to be added. So, that will be your interest rate multiplied by the unit cost. So, that will be cost of holding cost per unit per year. The next important cost is ordering cost. The cost which is considered fixed regardless of the order quantity, it covers the preparation of voucher and the processing of order including payment, postage, telephone, transportation, invoice verification, receiving and so on. So, for this company, the largest portion of the ordering cost involves the salaries of the purchasers. An analysis of purchasing process showed that the purchaser spends approximately 45 minutes preparing and processing an order. With a wage rate and fringe benefits cost for purchase of 20 hour per hour, the labor portion of the ordering cost is $15. So, the labor portion of this ordering cost is $15. Making allowances for paper, postage, telephone, transportation and receiving cost is $17 per order. The manager estimates that the ordering cost is $32 per order. How? $17 plus $15. So, the company is paying $32 per order regardless of the quantity requested in the order. We know that the holding cost is $2 and the ordering cost is $32. So, the holding cost is directly proportional to the inventory on hand, that is a quantity, but the ordering cost is independent of order quantity. The another point you should note, most inventory cost models use annual cost, whether it may be the holding cost, because the interest rate is generally it is for annual interest. So, when the holding cost is for annual, so the demand also should be expressed in units per year. So, the inventory holding cost should be based on the annual rate. So, that point you should, because all the cost and demand should be in the same unit. Calculation of order quantity. So, before knowing the ordering quantity, we should know the information about the holding cost, ordering cost and the demand information. We know what is the holding cost, that is $2, ordering cost is $32 and the demand also 2000 units per week. After developing these data, we can look at how they are used to develop the total cost model. Because why we are concerned about the total cost model? We have to find out the order quantity that will minimize the total cost. So, we begin by defining Q as the ordering quantity. So, this is the Q we are going to find out. So, the how much order decision involves finding the value of Q that will minimize the sum of holding and ordering costs. That is the logic behind this. So, we have to find the value of Q that will minimize the sum of holding cost and ordering cost. So, before finding this holding cost, first I will explain what is the meaning of this average inventory. The inventory for the company will have a maximum value of Q units when an order of size Q is received from the supplier. For example, you see say 0th month. So, here say 1200 units. So, this is your Q. What will happen? Suppose I have 1200 units in my hand. Assume that this is monthly demand. So, every month I am consuming 100 units. Okay. So, I will start from 1200, 1100, 1000, 900, 800 up to 0. So, here we should know what is the average inventory. So, this is maximum inventory, maximum value of Q. Here this is the minimum value of Q. So, when we know the average inventory, so Q maximum minus Q sorry plus Q minimum divided by 2, that is average value. Okay. So, what we should learn from this graph? So, the company received Q units, then the company will then satisfy the customer demand from its inventory until the inventory is depleted, at which time another shipment of Q units will be received. What will happen? So, I am starting from the 1200 units, it will come to 0. So, again I will get 1200 units. Okay, that is the meaning. Assuming constant demand, the graph of the inventory for the company is shown in this figure like this. Here what is the average inventory, as I told you? So, here Q maximum is Q only, okay. Q minimum is 0. So, upon 2, so the average inventory is nothing but Q by 2. So, Q by 2 will be here. So, this is my Q by 2. Note that the graph indicates an average inventory is Q by 2 for the period in the question. This level should appear reasonable because the maximum inventory is Q and the minimum is 0 and the inventory declines at a constant rate over the period. So, what is the formula for average? Maximum plus minimum upon 2. Q minimum is 0. So, it is only Q by 2. Now, we will discuss about complete inventory pattern. Previously, it is done for only one cycle. Okay. The figure in the previous slide shows the inventory pattern during one order cycle of the length T. As times go on, this pattern will repeat. You see this is pattern 1 and pattern 2. So, this figure shows the complete inventory pattern. If the average inventory during each cycle is Q by 2, the average inventory over any number of cycle is Q by 2. So, over here also it is Q by 2. For this cycle 2 also it is Q by 2. In this there are 2 cycles. Now, calculation of annual holding cost. We have seen average inventory. Now, we will calculate the annual holding cost. The holding cost can be calculated using the average inventory. That is, we can calculate the holding cost by multiplying average inventory by the cost of carrying 1 unit in inventory for the stated period. The period selected for the model is up to you. It could be 1 week, it could be month or 1 year or more than that. However, because the holding cost for many industries and businesses is expressed as an annual percentage, because interest is generally expressed for annual. Most inventory models are developed on an annual cost basis. So, annual cost of holding 1 unit in inventory. Let I be the annual holding cost rate, C be the unit cost of the inventory item. So, CH is the annual cost of holding 1 unit in inventory. So, the annual cost of holding 1 unit in inventory, that is CH, is equal to I multiplied by C. Here the CH is the cost of holding 1 unit inventory for 1 year. Because smaller order quantities, Q will result in lower inventory. The total annual holding cost can be reduced by using smaller order quantities. If the value of Q is small numbers, the inventory holding cost will be lesser. But what is the problem? We have to frequently order. So, what will happen? There will be more number of orders, so the ordering cost will increase. The general equation for the annual holding cost for the average inventory of Q by 2 unit is as follows. What is that? The annual holding cost is equal to average inventory multiplied by annual holding cost per unit per year. So, Q upon 2 multiplied by CH, that is annual holding cost. Now, we can calculate the annual ordering cost. The goal is to express the annual ordering cost in terms of the order quantity Q. The first question is, how many orders will be placed during the year? So, how many orders? That means the number of orders multiplied by the ordering cost, that will give you the total, the annual ordering cost. So, we should know how many orders. Generally, how will you find out the how many orders? Let D denote the annual demand for the period. For the cold drink company which we are discussing, so the demand equal to annually 52 weeks, per week demand is 2000, the total it is 1,04,000 cases per year. We know that by ordering Q units every time we order, we will have to place D by Q orders, total demand divided by number of units order, that will be the number of quantity Q, that will give you the number of orders. If CO is the cost of placing one order, the general equation for the annual ordering cost is, so annual ordering cost is number of orders per year multiplied by cost per order. What is the number of orders? D upon Q. What is the D? Annual demand. Q is quantity ordered. CO is cost per order. For a given annual demand of D units, the total annual ordering cost can be reduced by using larger order quantities. When you order large quantities, number of orders will decrease. When the Q is bigger, number of order will decrease, so that the annual ordering cost will decrease, will be less. The CO, that is ordering cost, the fixed cost per order, it is independent of the amount ordered. Whether you order one quantity, whether you order 50 quantity, okay, that is independent of the amount of order. It is only based on the number of orders. The total annual cost is the summation of annual holding cost plus annual ordering cost. So, Q by 2, that is average inventory multiplied by holding cost plus number of orders multiplied by cost per order, CO. In our problem, so here I represents, so 18% for interest plus 7% for some other expenses. So, 25%, the value of I is 25%, so 0.25. The unit cost, C is the unit cost, $8, so it will be $2. What is the $2 holding cost? Ordering cost is $32, the demand is 1,04,000. So, the total cost is, I am substituting these values into this equations. So, Q upon 2 multiplied by 2, demand divided by Q multiplied by 32, I am getting this expression, Q plus 33,28,000. So, this is the expression for our total cost. Now, I am going to use Excel to find out how much to order. So, I have taken holding cost $2, ordering cost $32, annual demand is 1,04,000. So, now I will open Excel. Now, you see D2 is my holding cost, D3 is my ordering cost, D4 is annual demand. Now, the ordering quantity from C7 to C18, C7 to C12, I am going to substitute randomly 5,000, 4,000, 3,000, 2,000, 1,000. Here I am going to find out, suppose if I order 5,000 units, what will be my holding cost. So, the D7, you see that formula in D7, average inventory So, C7 upon 2 multiplied by holding cost $2. Like that I have dragged for up to say ordering quantity 1824. Similarly, ordering cost, if I look at the formula in E7, what is the formula for ordering cost? Total demand is D4 upon C7 ordering quantity, that will be number of orders multiplied by ordering cost 32. So, it is 665.6. So, the total cost is the sum of holding cost and ordering cost. Here randomly I can substitute the value of Q. So, when you look at this, when I substitute randomly say 1824 for example, the ordering cost is minimum, how much? 3648. So, the optimal ordering quantity is 1824. You should remember the ordering quantity, the values in C column I have randomly substituted, but since I am doing trial and error, this is not the right way. So, what I am going to do? I am going to derive an expression for finding the optimal ordering quantity. Okay. So, not only that, you see the picture, when I plot, see the blue one says the holding cost, the orange one says ordering cost, the gray color shows the total cost. You see that the total cost, it starts from here, the total cost is minimum this point approximately 2000. I am not knowing the exact value because the exact value is 1824. So, the optimal ordering quantity is 1824. So, this 1824 I am going to derive by using the concept of minimum principle. So, I will go back to my presentation. So, this is see that suppose if you are not considering the 1824, you see the minimum total cost is here 3664. So, approximately if you order 2000 units, the total ordering cost will be minimum. Look at the relationship between total cost, ordering cost and inventory holding cost. The holding cost is high, right? Holding cost is high when you go for higher quantity. When you go for higher quantity, you see the ordering cost is very less. So, we need to have the trade off between holding cost and ordering cost. So, that is the total cost. Sum of this, the green color says the total cost. Here approximately here we are getting this Q star approximately 2000 units. So, we can derive, okay, the value of Q, okay, we can call it as a Q star from the expression of total cost. So, what we have to do? The total cost expression we have to differentiate with respect to Q and equate it to 0. So, the total cost expression is 1 upon 2 Q C H plus D upon Q C 0 is equal to 0. When you differentiate, so it is a Q, so it will be only C H by 2 plus the differentiation of 1 by Q is minus 1 by Q square, that I have written as a Q to the power minus 2. So, when I simplify this, the Q square is 2D C naught divided by C H. So, the Q star is, when I take the square root of this, 2D C 0 C H. So, when I substitute these values, D I know demand, ordering cost I know $32, I know holding cost, then the exact quantity is 1824. So, if I order this many quantities, instead of 2000 was the approximate value, if I order 1824 units, my total inventory cost, that is the summation of ordering cost and holding cost, will be minimum. So, the total cost for Q star, that is when you order 1824 is, what we can do, if I go back to my Excel, you see that the last C12, when I wrote a 1824, the total ordering cost is, the total cost is 3648. So, how I can get this 3648? I will go back to my presentations. So, when I substitute the value of Q 1824, I am getting the total annual cost is 3648. So, this value we have verified with the help of Excel also. So, what we are concluding, the optimal order quantity is 1824 units. In this lecture, I have discussed about the importance of inventory. Then I have explained how to calculate the holding cost and ordering cost. Then I have explained how to find the total cost. From the total cost expression, I have derived the formula for economic order quantity, that is a Q star. So, that will answer this question, how much to order. The same how much to order I have explained with the help of Excel also by changing different order quantity. Then I have shown you how the total cost varies. In the next class, I will answer this question, that is when to order inventory decisions. So far we have found how much to order. So, the answer for when to order I will do in the next session. Thank you very much.